So the starting point is point A. So this is your point C here. Let's take a point C here. And then this on line BC. So we'll now draw the line perpendicular to line BC. Now draw this line which is perpendicular to, so the starting point is point C, and then this line is perpendicular to point C. Don't forget we have chosen the scale of 1 centimeter equals 1 meter per second. And since we have the velocity at 7.5 meter per second, it means we are going to measure 7.5, that's 7.5 centimeter. From here to here is going to be 7.5 centimeter. So now this is for your crankshaft BC. So the direction of your arrow is going to be this way, because you are starting from point C, you are going towards point B. So this is velocity of B with respect to C. So now we are going to consider AB. So this is your AB. You also take you also construct another line which is that perpendicular to AB. So you can see that this ruler is directly on AB. You now take your set square, place it here. So you now draw this line passing through point B here. We don't know the direction. First you just draw that line passing through point B. So this is the line. Then you can take your ruler and then you can extend the line in both sides. So now we don't know the direction of this line yet, but we know that our A is going to be somewhere. You know this is your point B, so our A is going to be somewhere on this line. So now we need to consider the velocity of the slider. This A here is the velocity of your slider. So we are going to take velocity of A with respect to C. So that means C is the starting point, then A is the final point. So we are taking the velocity of A with respect to C. So we know that A moves horizontally on this fixed line. So A is going to move horizontally. So it means we are going to have a line which is drawn horizontally through point C here as well. So it means whatever line you are going to draw is going to be horizontal through point C, and it's going to be parallel to line AC. It means you are going to find a way of drawing a line which is parallel to line AC. So now you take this, your set square, so you can see it's parallel. You just drag it down here, and then you draw a line which is parallel. So now we've been able to locate point A. So our point A, small letter A, is going to be here. So initially, you remember we said A is going to be somewhere on this line. So automatically, this is where your point A is. So the direction of your arrow is going to be from C to A, because it is velocity of A with respect to C. C is the initial point. So now we need to find the velocity of point G. So on the configuration diagram, your G is somewhere here, is somewhere on your connecting rod, but the distance of point G here is 100. It means that from here to here is 100 mm. So it means we need to locate point G on line AB here as well. So now this is your BG over BA equals small bg over small BA. Capital BG over capital BA equals small bg. So this capital BG is from the configuration diagram and from what we have been given the question. BG is given by 100, while BA is given by 300. So also we are looking for BG from this velocity diagram. So we need to measure BA. So we need to measure BA or AB. So when measure after measuring, so that's around 3.95 centimeter. So from here we can make BG the subject of the formula, and then we get BG as 1.3 centimeter. So it means from point B to G, we are going to locate 1.3 on line AB here. So automatically this is your point G. You're now drawing a line from point G to midpoint C. So this is the line using short dash line, and then the direction of your arrow is going to be from point C to point G, because C is the starting point, then G is the final point. So now the velocity of G with respect to C is now going to be the velocity we are looking for. So you just take a ruler, you measure length CG. So that's around 6.65 centimeter. So it means your GC is 6.65 centimeter. So that answers number 1. So it means velocity of G with respect to C is what? 6.65 centimeter. So you now convert it back to meter per second. That will be 6.65 meter per second because of this scale we have used. So now going to number 2, we are expected to find the angular velocity of what? AB. Angular velocity of AB is given. It's given by velocity of AB all over radius of AB. So now, what is the velocity of AB? Velocity of AB, you can get it from the velocity diagram. All you just need to do is measure it, and whatever we get, that's going to be a velocity. AB is already, this is it here, or B here. That's already, so that's going to be 3.95. It's still 3.95 centimeter, is 3.95 meter per second based on the scale we have used. Over what? What is the length AB? The length AB from the question is 0.3 meter or 3 mm. That's AB, that's 300 millimeter or 0.3 meter. So that will be this divided by 0.3. It means the angular velocity of a connecting rod AB is given by 13.2 rads per second. So that's going to be in the clockwise direction about center B. So now looking at the configuration diagram, B is center to A and C. Now looking at the velocity diagram as well, we are expect the direction of the arrow is going to be from B towards A, because we are going to find the velocity of A with respect to B. A with respect to B. So B is the starting point, A is final. It means A, velocity of A, so that's why the direction of the arrow is this way. So now we need to find the third and the fourth solutions. So the third one, we are expected to find